Hi there, welcome back to the Mad Skill series on Jetpack DataStore. In this episode, we will learn about Proto DataStore, one of two DataStore implementations. We will discuss how to create it, read and write data, and how to handle exceptions, to better understand the scenarios that make Proto DataStore a great choice for you. Proto DataStore uses typed objects backed by protocol buffers to store smaller datasets while providing type safety. It removes the need for using key value pairs, making it structurally different from its share preferences predecessor and its sibling implementation, Preferences DataStore. However, that's not all. DataStore brings many other improvements over share preferences. Feel free to jump back quickly to our first episode in the series and take a look at a detailed comparison we made there. Going forward, we will refer to Proto DataStore as just Proto unless specified otherwise. To quickly sum up, Proto relies on Flow's error signaling mechanism, allowing you to efficiently catch and handle exceptions when reading or writing data. It provides a fully asynchronous API for storing data using the power of Kotlin coroutines and Flow. It also comes with a mechanism for quick data migrations. To start using Proto DataStore, you need to get familiar with protocol buffers, a language and platform-neutral mechanism for serializing structured data. It is faster and smaller than XML and easier to read than other similar data formats. Now, let's move on to some code to learn how Proto works. We will use the Proto DataStore code lab sample. If you prefer a more hands-on approach with full implementation, make sure to check out the Working with Proto DataStore code lab. This sample app displays a list of tasks, and the user can choose to filter them by their completed status or sort by priority and deadline. We want to store their selection, a Boolean for displaying completed tasks, and a sort order enum in DataStore. We will firstly look at Proto dependencies and some of the basic Protobuf settings in our module's build Gradle. If you're interested in a more advanced customization of the Protobuf's compilation, check out the Protobuf plugin for Gradle notes. Firstly, this requires adding the Protobuf plugin ID, as well as the dependencies for both DataStore and Protobufs. The plugin adds a Protobuf block in your module's build Gradle, which allows us to configure the Protobuf compilation. Here we specify which repositories to download from, how the compiler should generate the code, and configure the task's output type. We're using Java Lite as it has smaller code size and is the recommended option for Android. Our journey with Proto DataStore starts by defining the structure of your persisted data in a proto file. Think of it as a readable schema for you and a blueprint for the compiler. We name ours users prefs proto and add it to the app's proto directory. Following the Protobuf language guide in this file, we will add a message for each data structure we want to serialize, then specify a name and a type for each field in the message. Next is our message definition. A message is an aggregate containing a set of typed fields. Many standard simple data types are available as field types, including booleans, ints, strings, and others. You can also add further structure to your messages by using other message types as field types, like we did with sort order here. These markers on each element identify the unique tag that the field uses in the binary encoding, like an ID of sort. Once your message type is in use, these numbers should not be changed. When you run the protocol buffer compiler on a proto file, the compiler generates the code in your chosen language. In our specific case, when the compiler is run, this leads to the generation of the user preferences class, found in your app's build proto directory. You can also try out the newly announced Kotlin DSL support for protocol buffers to use a more idiomatic way of building your data model. Now that we have user preferences, we need to specify the guidelines for how Proto should read and write them. We do this via the DataStore serializer that determines the final format of your data when stored and how to properly access it. This requires overriding default value, what to return if no data is found, write to, how to transform the memory representation of our data object into a format fit for storage, read from, inverse from the above, how to transform from a storage format into a corresponding memory representation. To keep your code as safe as possible, handle the corruption exception to avoid unpleasant surprises when a file cannot be deserialized due to format corruption. You interact with Proto through an instance of the DataStore interface, which grants access to the persisted information, in our case in the form of the generated user preferences. To create this instance, it is recommended to use the delegate DataStore and pass a mandatory file name and serializer argument. We will talk about the produce migrations parameter a bit later when we discuss migrations from shared preferences. File name is used to create a file for storing the data. This is why the DataStore delegate is a Kotlin extension property whose receiver type must be an instance of context, as this is needed for the actual file creation. Avoid using this file in any way outside of Proto, as it would break the consistency of your data. In the DataStore delegate, you can pass one more optional argument, corruption handler. This handler is invoked if a corruption exception is thrown by the serializer when the data cannot be deserialized. Corruption handler would then instruct Proto how to replace the corrupted data. You shouldn't create more than one instance of DataStore for a given file, as doing so can break all DataStore functionality. In this code lab, we construct the instance at the top level of the activity for simplicity and pass it as a singleton. In later episodes, we will see how to do this via dependency injection. To read the stored data, in user preferences repository, we expose a flow of user preferences from DataStore instance. This provides efficient access to the latest saved state and emits with every change. This is one of the biggest strengths of Proto. Your flow's values already come in the shape of the generated user preferences. This means you don't have to do any additional transformations from the saved data into a Kotlin data class model, like you would with shared preferences or preferences DataStore. The flow will always either emit a value or throw an exception when attempting to read from disk. We will look at exception handling in later sections. DataStore also ensures that the work is always performed on dispatcher's I/O so your UI thread isn't blocked. Do not create any cache repositories to mirror the current state of your Proto data. Doing so would invalidate DataStore's guarantee of data consistency. If you require a single snapshot of your data without subscribing to further flow emissions, prefer using the first flow operator. For writing data, we will use a suspend update data function that takes in another suspend transform function. We can use this to change our show completed Boolean. Let's break that down. We're currently using the user preferences store as the concrete implementation of our data store. The transform suspend block is used to apply the specified changes to our persisted data of type T. Protocol buffers simplify the write process as well, removing the need for any manual transformation from and to data classes. There's a few steps to analyze here. ToBuilder gets the builder version of our current preferences, which unlocks it for changes. SetShowCompleted sets the new value. Finally, the build finishes the update process by converting it back to user preferences. Updating data is done transactionally in an atomic read, modify, write operation. Only after the transform and update data coroutines complete successfully, the data will be persisted durably to disk and user preferences store flow will be reflecting the update. Keep in mind that this is the only way of making changes to the data store state. Keeping a user preferences reference and mutating it manually after the transform completes will not change the persisted data in Proto, so you shouldn't attempt to modify user preferences outside of the transform block. So that covers Proto DataStore reading and writing. Now, if you've previously used shared preferences in your app and would like to safely transfer its data to Proto, you can use shared preferences migration. It requires a context, shared preferences name, and an instruction on how to transform your shared preferences key value pairs to user preferences within the migrate parameter. Pass this via the produce migrations parameter of the data store to migrate easily. In this example, we go through the process of building the user preferences and setting its sort order to what was previously stored in the corresponding shared preferences key value pair, or simply defaulting to none. Produce migrations will ensure that the migrations are run before any potential data access to DataStore. This means your migration must have succeeded before DataStore emits any further values, before it begins making any new changes to the data. Once you've successfully migrated, it's safe to stop using shared preferences, as the keys are migrated only once and then removed from shared preferences. The produce migration accepts a list of data migrations. We will see in later episodes how we can use this for other types of data migrations. If you don't need to migrate, you can ignore this as it has a default list of provided already. One of the main advantages of DataStore over shared preferences is its neat mechanism for caching and handling exceptions. While shared preferences throws parsing errors as runtime exceptions, leaving room for unexpected, uncaught crashes, DataStore throws an I/O exception when an error occurs with reading or writing data. You can safely handle this by using the catch flow operator and emitting some form of backup data, for example, get default instance of our user preferences. Or we can just add a try-catch block for writing data. If a different type of an exception is thrown, prefer rethrowing it. We've covered protocol buffers and DataStore's proto implementation, when and how to use it for reading and writing data, how to handle errors, and how to migrate from shared preferences. The next 2 episodes, we will go a step further and look at how DataStore fits in your app's architecture, how to inject it with Hilt, and of course, how to test it. So hit subscribe and see you soon.